Hello everyone, my name's Alex from agrade.tech, and today I want to give you my favorite shortcut for finding the network address of a given IP and mask. First, small disclaimer, if you're having a lot of trouble with subnetting, you should at the very least be aware of what's going on with the binary. You don't have to be a binary master, you don't even have to use the binary methods ever again once you understand the basics of what's going on. Understanding the binary will help you learn how to use this shortcut and any other shortcut for any kind of subnetting question. There's really no way around it. I didn't want to learn it at first. It seems weird, zeros and ones and operations and all that, but it's not that bad. And at the bottom of the article and in the video description, I'll post some links to the best videos I can find on the binary. So once I'm referring to turning bits on and off, and you know what the binary is, what's happening there, this will make a lot more sense. So let's get into it. What we're going to go over is the thought process for solving a problem type. For example, what is the network address of 6.9.19.96/23? Old way I used to do it would take minutes. Now I'm down to seconds, so it really saves a lot of time. We'll use a subnetting tool to practice and review after we go over the first example. I'll show you a question type that this is useful for, when you need to be able to do this. Then we'll have a conclusion and talk about what's coming next. So for example, what is the network address of 182.165.0.237/27? First thing you need to understand is the bit values for each bit position. You should have seen this before because you understand what's happening at the binary level. There it is, 128, 64, 32, so on. Step one for this trick is finding the interesting octet. In this case, we have a /27, so we know that the first three octets are not changing. That would be a /24. This makes the so-called interesting octet the last octet because this is where our subnet bits stop. We know that each octet is 8 bits, so from the third, which would be 24 bits, we need to borrow 3 to get to 25, 26/27. Now we draw a line where those subnet bits stop and where the host bits begin. So draw a line to the right of the last subnet bit, in this case between 32 and 16. Fun fact, the networks increment by 32 for this mask. That's your magic number, they call it. So the first network would be .0, the second subnet would be .32, the third subnet would be .64, so on. The next step for finding the network address where this IP lives is we need to subtract the bit values from the number in the interesting octet until we reach 0, or we cannot subtract without going negative, or we reach that dividing bar where the subnet bits stop and the host bits begin. So every bit you can subtract, you turn that bit on. That sounds confusing, but it's not, so let's take a look at what I mean. The value of the interesting octet in this case is 237. So can you subtract 128 from 237 without going negative? Yes, you can. So turn on that bit, and that leaves us with 109. Can you subtract 64 from 109 without going negative? Yes, you can. Turn that bit on. That leaves us with 45. So basically 237 minus 128, 109 minus 64. That leaves us with 45. Can you subtract 32 from 45 without going negative? Yes, you can. So turn on the bit. And this is where we stop because we met our dividing bar. This is where the subnet bits stop and where the host bits begin. Once again, once you either reach 0 or you reach the dividing bar where the subnet bits stop and the host bits start, or you can't subtract anymore without going negative, this is the value of your network address. So every bit that you've turned on, add those values together. In this case, we turned on all three of them. So 128 plus 64 plus 32 equals 224. So what is the network address where 182.165.0.237/27 lives? The answer is 182.165.0.224/27. So one more time, find your interesting octet, subtract the value of the subnet bits from that value until you either reach 0 or you reach the dividing bar or you can't subtract anymore without going negative. Add up the value of the bits that you turned on. That's the value of your network. An example where this question comes in handy. So why can't A and B ping the router? Here's our topology. The router's .9, PCA is .6, PCB is .5. Why wouldn't PCA be able to ping the router and PCB be able to ping the router? In this case, they could ping each other, though. Why do you think that is? Well, it's because the router's in a different network. Basically, the PCs are in the first subnetting, .0, and the router's in the next subnetting, which would be .8. So this is why it comes in handy to be able to quickly find the network address of an IP in the mask. In the exam or in real life or whatever, sometimes the numbers are a lot more confusing than that. It may not be so obvious. If this was obvious to you, congratulations. Okay, let's do a couple more examples. Just erase this real quick. Do a couple more examples just so we can hopefully run into a couple more situations. The tool I'm using here is something I made in Python. It's not finished. There's some problems with it. I'll link to the code on GitHub. You can take a look at that if you're interested, but just check the links and you can read more about that somewhere else. So in this case, we have the question, what is the network of 204.92.1.192/26? Because it's a /26, we know we're looking at the last octet because we have 8, 16, 24, 25, 26. We need to borrow 2 bits. We'll draw our line here. Now, on the exam or in real life, you'll have pen and paper. You can do this math. You will not have a calculator. Some of you are really good at mental math, and you're laughing at me because I'm not, so that's fine. But anyway, 192 minus 128. A lot of you already knew, come on, dude, it's 64. So you turn that on. Interestingly enough, you turn this one on too, and we've reached 0. So 128 plus 64 is 192. So, interestingly enough, this is the network address. This is totally random. So it's kind of cool to get that example. But as you can see, that's the network address of that network. Let's do it again and see what we get. /3, that's a super netting question, so try again. Another /26. Let's go again. I want to get a different example here. /15. Okay, that's cool. So we'll erase this. And this is live on the spot, as you can see, so this illustrates how quick the method could be. Anyway, because it's a /15, we know we're looking at the second octet here, and we borrowed everything except 1 bit. This is where our line goes. The only bit we can turn on, because we're looking in the second octet here, is 4. That leaves us with 1. That's the only one we can turn on. So the network is 143.4.0.0. As you can see, that's the right answer. Let's do another one. That one was quick. Okay, cool. /27. So in this case, 64.244.172.251/27. We're in the last octet, 24, 25, 26, 27. Networks increment by 32. Yes, we can subtract that. So 251 minus 128 is 123. We can subtract 64. We can subtract 32. Most of you knew that. I'm mainly just illustrating here. It's not because I'm bad at math, I promise. Anyway, we turn on all the bits. Then we add them up. 224. So the network here is 64.244.172.224. As you can see, that's the right answer. We'll just do one last one. /21. Nice. We got a different one this time. So in this case, we're in the third octet because we know 8, 16, 24. So 16, 17, 18, 19, 20, 21. This is where we draw our line. Our value is 217. Yes, you can subtract 128 from 217. Leaves us with 89. Yes, you can subtract 64 from 89. No, you cannot subtract 32, but you can subtract 16. And in this case, we can subtract 8, and we stop because we met our line. What did we turn on? 128 plus 64 plus 32. Oh, not plus 32. Plus 16 plus 8. Value is 216. So in this case, our network is 245.29.216.0. As you can see, that's the right answer. Now, just for those of you who could use a little bit of review, you should have watched the binary, so you already know this, but 217 minus 128 minus 64 minus 16 minus 8. We have 1 left, so we'll turn that on. The binary for the value 217 is 110110001. And we can illustrate that by 128 plus 64 plus 16 plus 8 plus 1, 217. So that's a little, I'm not going to get much further into it than that, but that's kind of what's going on with the binary here. Then to find the networks and all that, you can do an AND operation. But like I said, just check the links, and whoever I've linked to should provide an excellent explanation of what's going on there. So let's go ahead and wrap up. So what's next? You tell me. Some of you guys came across this video from signing up for my EIGRP, OSPF, GRE tunnel lab. If you didn't get that lab, there's a link to it in the description or at the bottom of this article. Some of you might be first-time viewers. So basically just tell me what other things you'd like to go over if my teaching is helping you. It's helping me understand it as well, so that's partially why I do it. But things I'm thinking about are, STP, maybe some of the more advanced side of OSPF, route installation, how is something installed in the routing information base or the routing table. So just send me an email, leave a comment on the article, however you want. Let me know what kind of topics you would like to see from another perspective, and I'll work on putting something together. So thank you for watching. I hope this was helpful. I hope it wasn't too painful watching me do some of that math. Some of you guys are mental math wizards, and we're like already knowing the answer. So it's good because it shows you don't have to be really good at mental math to be quick with subnetting. Some of the answers or some of the questions here were obvious. Sometimes they will be much less obvious, especially if you're trying to study for the CCNA or something like that. So this is my favorite method. I used to do it in the way where, if the magic number was 32 and the number was like 220 whatever, I'd be like, oh, 0.32.64. And like I already showed and exposed, I'm really bad at math. What's 64 plus 32? Well, it's, 96? I'm pretty sure that's the answer, but it might not be. And there's a lot of error in that method. Sometimes the networks are incrementing by 4. And you got to get way up there, and it just takes a lot of time. It's a waste of time. Every question you can answer quicker on the CCNA buys you more time to troubleshoot something more complicated. So going on and on here, video was longer than I wanted. Hopefully it helps some of you. And like I said, let me know what you want to see next. Thanks for watching.